Hello students, see this question from IITJEE 2015. We have two stones are thrown up simultaneously from the edge of a cliff, 240-meter high, with initial speed of 10 meter per second and 40 meter per second. Which of the following graph best represents the time variation of relative position of the second stone with respect to the first? So we have got two stones. They are thrown from a height of 240 meters. I'm sorry, right, 240 meters. One stone is thrown up. Let's name them. This is your stone one and this is your stone 2. So stone 1 is thrown up with 10 meter per second and stone 2 is thrown up with 40 meter per second, correct? And that's thrown up simultaneously. Now we have to find the variation of relative position of the second stone with respect to the first stone. So for that, let us first of all find out what is the time duration after which the first stone will fall to the ground. So the displacement of the stone is how much? It is going up and then coming down, but its initial position and final position have a displacement of 240 meter. Its total displacement is minus 240. Why minus 240? Because you're going down. I'm taking downward direction as negative, upward direction as positive. Now, S we are using the formula S equal to ut plus at square by 2. So u is 10, u is 10 upwards, okay, and acceleration is g downwards. So we will use it as minus 10, minus 10 t square by 2. So when you solve this quadratic equation, you will get t will come out to be equal to 8 seconds. Okay. So the first object is taking 8 seconds to reach the ground. So before 8 seconds, it is still in air, and after 8 seconds, it will not be in air anymore. Okay. So for time between 0 to 8 seconds, acceleration of the first ball is g downwards. I could write down minus g. Acceleration of second ball is also g downwards, so minus g. So relative acceleration will be 0. Relative acceleration means what? A2 minus A1. Okay, I'll write it over here. This is equal to A2 minus A1, that will be 0. Alright. Therefore, relative, since relative acceleration is 0, so relative velocity will be constant. So for constant relative velocity, your displacement time graph is a straight line. So for constant relative velocity, we have the displacement time graph straight line for all the 4 cases, right? Okay. Everywhere we have the displacement time graph to be equal to straight line. Okay. Then now the question remains that after 8 seconds, when the first ball has reached the ground, the second ball is still in the air. So now there will be no zero acceleration. Okay, for t greater than 8 seconds, acceleration of 1 is 0 while acceleration of 2 is minus g. Correct. So relative acceleration is now equal to a2 minus a1, that is equal to minus g. It is not 0 anymore. But since acceleration is negative, so for negative acceleration, your graph is of this shape. Xt graph is like this. Okay, inverted U shaped. So in which case are you getting inverted U shape? Here you are getting the inverted U shape. Okay, only this part. We are looking only at this part, and this is inverted U shape. So we'll mark option A.